Hello and hi, my name Muhammad Akmal bin Maisa, together with my teammates, and today we will explain about the Pascal law. We all understand that law without force is important from Blaise Pascal. The next slide will explain about introduction. Will explain from Karunisa.
Thanks to Akmal. So now I would like to present about what is Pascal's law. The Pascal's law was proposed by Blaise Pascal. He was French physics and mathematician. Pascal principle is used to quantitatively relate the pressure at 2 points in incompressible static fluid. He said that pressure is transmitted undiminished in a closed static fluid. A static liquid can be utilized to generate a large output force using a much smaller input force, yielding important devices such as hydraulic presses. So next, I would like to present about Pascal law state is that pressure at any point in a body of fluid is the same in every direction, exerting equal force and equal areas. This work for gas and liquids. There is the picture show how Pascal law works. As you can see from the picture, there is an external pressure applied from the outside, and then the pressure will transmit equally in all directions. So now I would like to pass to Daniel to explain about the Pascal formula that we can use to do the calculation in Pascal law.
Thank you, Karunisa, for giving me the opportunity to continue with this presentation. My name is Muhammad Daniel bin Muhammad Sham. So I will be explaining about Pascal's basic formula. The basic formula that is used in Pascal's law is as shown in the slide. The formula consists of three components, which is force, pressure, and area. Next, a variation of Pascal's law. As referred in the slides, to find pressure, force must be divided by area. P equals to F over A. To find force, pressure must be times with area. F equals to P times A. And to find area, force must be divided by pressure. A equals to F over P. Furthermore, the formula can be derived even more. We will explain it later in the application of Pascal's law in our daily life. For further information, refers to Blaise Pascal, a French scientist. It is observed that the pressure in a fluid at rest is the same at all points, given that they are at the same height. That's all from me. Thank you for lending your ears. I will now pass to Anis to continue with our presentation.
Thank you, Daniel. So my name is Nurul Anis, and I'm going to explain about the Pascal application and their example. So as stated from Karunisa before, Pascal law states that the pressure applied to a fluid in a closed container is transmitted equally to all points in the fluid and act in all directions of the container. So Pascal law is also applicable to both solids and liquids. So next, in Pascal application, there are four types of example that we can see from our daily life, which is we have hydraulic lift, hydraulic jack, hydraulic brakes, and also hydraulic pump. So first, the Pascal law can be applied to the hydraulic lifts. Hydraulic lift is a multiplication of force that can be achieved by the application of the fluid pressure according to Pascal principle, and it's involved with two pistons. So hydraulic lift will work as a multiplied force by hydraulic press, and for that I will show a short video on how the lift simulate. So Pascal law states that, as I said before, this principle can be applied to the hydraulic lift for lifting a heavy object. So in this simulation, we will see how the hydraulic lift works. So here we can consider a liquid container which consists of two pistons. We have A and B, which is fitted into cylinder with areas A1, which is a small part, and then the A2, which is the larger part. So according to the Pascal law, when a pressure P is exerted over the larger area A2, thus giving a greater force F and leads to a pressure P2 over the piston B, which is this pressure P2 is used for lifting the automatic place over the piston B. So the calculation can be, as you can see, can be P1 equal to P or F1 divided by A1 equal to F2 divided by A2. So when F1 is reduced by piston A, F2 is also reduced by pressure. So as you can see, the process when F1 is reduced by releasing the piston A, F2 is also reduced proportionally as I said before. So hence the piston B comes back to its original position. So this is an example, the same example as the video shown. It is a process of the hydraulic lift. So I will continue with the second application, which is the hydraulic jet. Next. So hydraulic jet also use Pascal principle to work. So to explain, hydraulic jet is a device that is used to lift heavy loads by applying a force via a hydraulic cylinder. So the jet will lift load using the force created by the pressure in the cylinder chamber. So there is a short video that will explain on how it works. So in this video, we have an example of water jet, which is we have consists of a jack handle, pump piston, check valve, release valve, a reservoir, and ram. So as you can see, the simulation. So the water jet works when the handle is pulled. You can see the oil reservoir flow through the check valve one, and after the first pull, the check valve will close, and then when you pull again, the oil will go through the check valve two, as you can see, and the oil will enter the bottom of the load cylinder, and you need to repeat the cycle as you need it. And next, when the release valve is open, the oil will from cylinder to reservoir, and the ram will go down. So this is a simple simulation of hydraulic jet, just the bottle jet. So next, this is the other example that we can see from our daily life, which is we have the garage jack, floor jack, and also as explained, we have the bottle jack. So to explain further about the other examples of application, I will pass to Shazwani to continue. Thank you.
Okay, thank you, Anis. So my name is Nushazwani. I'm gonna explain to you the third application is hydraulic brakes. Hydraulic brakes is an arrangement of braking mechanism. So what is hydraulic brakes? It transfers pressure from the controlling mechanism to the braking mechanism. And it also uses brake fluid typically containing ethylene glycol. Next. So firstly, I'm gonna get through you the simulation first, and I'm gonna explain afterwards. So I will explain to you about the simulation. So when the force is applied to the left piston, and the fluid will transmit the force to the right piston surface, but it will be a factor of the ratio at two piston surface. Then when you apply the brake, the caliper will receive the high pressure hydraulic fluid from the brake cylinder. The fluid will push the piston, which makes the inner brake pad to squeeze against the disc rotor surface. There you're going to see the fluid is pushing the piston to brake pad and piston pushing the brake pad to rotor. As a result, the fluid backward force will push the caliper along the slide pin, which makes the auto brake pad to squeeze this again at the disc rotor. So this is lastly about the hydraulic brakes. This is example how the hydraulic braking system be functional. So you can see the hydraulic braking system have a brake pedal, master cylinder, calipers, disc breaker, drum brakes, and drum. So at the right, when the brake pad force in the cylinder on the brake shoes, there you're gonna see force on the brake fluid by brake pedal mechanism, and friction force of the brake pad against the metal brake drum provides the braking force to stop the car, and the brake cylinder act as a double hydraulic press. So that's all for me, and I'm going to pass to Akmal. Thank you.
Thank you, Sazwani. The last one, I will explain about the hydraulic pumps. The hydraulic pump is used in hydraulic drive system and can be the hydrostatic and hydrodynamic. What is the hydraulic pump? The pump is a mechanical source of power that convert a mechanical power into hydraulic energy, generate, flow enough power to overcome pressure included by the load and the pump outlet. The next slide, I will show you the simulation about the hydraulic pumps. Okay, as you can see, the variable plunger pump has 5 components that plunger casing, shaft, swath plate, valve plate, and cylinder block. And at this video, it will show you about the operation system at this pump. Okay, that's all. Next. Now the example for other pump. So in this example, he has input shaft, outer valve unit, the fluid lines, the torsion bar, the inner valve, and the connection to input the valve, and then the input output of the pump. Then this is the last one example from our team. Now finally we have come to our conclusion that the dynamic of effective compression therapy are explained by Pascal law, which is state that when a change in pressure applied to enclosed fluid is transmitted and diminished to all portion of the fluid and to the wall of its container. Now thank you for listening from us, and then that's all from my presentation. Thank you.